Okay, I was asked to work through one of these systems of equations. You've got nonlinear is what they are. So you could have anything from a parabola to a circle. You could have some lines mixed in there, but they are systems that involve two equations where one of them is something other than a linear equation. So I was specifically asked about one that looked something like this with the two equations that were provided. So the approach that I used on this one is what I typically call elimination. There's elimination and then there's substitution. Elimination tends to work a whole lot better because what ends up happening is you completely eliminate one of the variables in your initial process of solving. So I chose elimination because if you look at how these are kind of behaving, they really resemble one another in terms of how they're set up. They've got the same powers on your variables. They're already set up as fractions for you, and actually one's already positive, one's already negative. So I chose to get rid of the y variables that you see here because it's going to easily be done if I'll just multiply this entire first equation by 2. So that's what you'll see me doing here. 2 times 6 is going to give us 12 over x squared. 2 times 1 is going to give us 2 over x squared, and then 2 times 8 is going to give us the 16 that you see over here. And then I just copied down that second equation. So you'll see me put a plus sign here because now I'm adding these two equations up so that I will then eliminate that y variable that you see there. Hopefully you can tell the difference in my y's and my x's. But anyway, this is a y squared, and so is that. That's plus 2 over y squared, and then plus a negative. So those are gone, okay? That adds up to 0. And then this is 12 over x squared plus 2 over x squared. So that's a total of 14 over x squared. Adding your 16 and your negative 2 gives you a positive 14 there. To proceed in solving this for x, I chose to multiply everything by x squared to wipe that fraction out. So x squared times 14, turn around, divide by x squared, you're left with just a 14. And x squared times 14 gives you 14x squared. You'll see that I divided by 14. So you had a 1 equals an x squared. Then I found the square root of both sides, remembering to do the positive and negative version of that. So the square root of 1 is just 1. So I come up with two different values for x in this system, and the solution to this system, okay? That means I'm going to take each of these two different values for x and substitute them back in to either one of these two equations to then solve for y. So I chose the first equation. You'll see me putting a positive 1 in for x. So 6 over 1 squared plus 1 over y squared equaling 8. Well, 1 squared is just 1. So 6 over 1 is just 6. Plus 1 over y squared equals 8. Then you proceed to solve for y by subtracting 6 from both sides. 1 over y squared equals 8 minus 6 is 2. Multiply everything you see by y squared to eliminate that fraction. Will then give you 1 equaling 2y squared. Divide both sides by 2, so you have 1/2 equaling y squared. Find the square root of both sides to solve for y, remembering to do the positive and the negative version of that. What you see me doing here is rationalizing that denominator to come up with, and here again, you've got the plus or minus going on because we found the square root. So rationalizing that denominator gets me down to the square root of 2 over 2, and it is a plus or minus square root of 2 over 2. So when I actually go back to make my answers, substituting in that single positive 1 for x way up here actually produced two different y values, positive square root of 2 over 2 and negative square root of 2 over 2. So that's what you see these two solutions consisting of. Now I didn't show it, but when you substitute the negative 1 value in for x, it's going to do the exact same thing because when you square a negative, you're going to get a positive. So had I put a negative 1 here, turned around and squared it, it would have looked identical, okay? So you'll see me using that negative 1 x value to then produce the same exact two y values. It's kind of really messy in my writing, but the work would have looked identical basically, okay? So you end up having 4 different solutions. Just be careful typing them into MATLAB and you should be good to go.